Good morning, folks. So look, yesterday, I hope you came away from yesterday's talks with the impression that the COTS COTS control program using the IPM strategy is working reasonably well to meet its current objectives, etc. What I want to try and convince you about today is that while it might be suited for what we're currently doing, it's unsuited for what we will need to be doing in the immediate future. And if we keep doing what we're doing today, we are going to fail. And really what it is, so the task is going to change dramatically, and improving our monitoring and surveillance, completely changing the way that we do that, is really going to be fundamental to evolving the program to be able to meet that future challenge. A lot of the talks in this session will focus on particular methods, the results of those particular methods. I want to think more about the broader context of the monitoring objectives, the type of program we might put in place and how it might work. So monitoring, when we're in a program where we're trying to control or protect an asset by controlling a threat to that asset, the fundamental information that allows us to make decisions, that allows us to plan for effective management responses, is information about the distribution of that asset, its characteristics, and the threats to that asset. We need that information. It needs to be highly location specific. It needs to be we need to be collecting at a high temporal frequency. We need that same sort of information for the threat that we're facing. We need to understand where it is. We need to understand how big a threat it is in particular locations. We need to understand, in the context of COTS, things like population size structure. That's the context in which our control program's operating, and it's the space that we have to distribute our effort and our strategies over. But we also need to be monitoring the control program itself so that we can understand its performance and so that we can start tweaking it to improve its performance. So those are the general areas where we need to be conducting monitoring and surveillance. And as we go through the outbreak cycle, different phases of that outbreak cycle, from the inter-outbreak period, initiation, establishment to full outbreak and then decline, the emphasis that we place on those different kinds of attributes and the kind of inferences that we're trying to make about the data that comes in from the field, it changes slightly, or it can change quite dramatically actually. So for example, in the inter-outbreak period, we're really interested in trying to get a baseline for coral cover so that we can estimate when we're actually losing or gaining. We need to get baselines on what is a low density COTS population, and so that we can detect changes that take us away from those, breaches of a particular density, etc. When we're in the full outbreak cycle, we need to know where to distribute those resources, and so our focus shifts more to guiding the control. So monitoring needs occur right throughout the outbreak cycle, and the emphasis changes slightly. Now, the challenge for the current control program has been that really it's been a matter of how do we effectively distribute our resources and go across an existing outbreak that we've got fairly well characterised. And it's actually a really simple problem that we've been dealing with. We've only got 260 reefs. It's a relatively static number. And we're simply moving through those reefs in an orderly fashion, controlling COTS as we go. We understand where the animals are, generally speaking, and our focus is really on just monitoring the progress of the control program. When we go to the future outbreak, however, things change dramatically. We're actually trying to achieve a whole range of objectives. Our primary objective as we move out of this outbreak and into the next outbreak is going to be to ensure that we're able to detect and prevent outbreak initiation. So that means we're going to have to know about our baselines, and we're going to have to be able to detect instances where we start leaving those baselines and heading towards trouble. And the scope of this suddenly becomes much, much larger. We're no longer talking about a static set of 260 priority reefs, could be any reef on the GBR. It's probably going to be in the initiation box, but could be anywhere else as well. And if we're going to achieve that objective, we have to effectively monitor at very large scales. The second objective, if we fail to prevent initiation, is then going to be to respond to the establishment of an outbreak. And we're going to start to move towards preventing spread and protecting coral cover. All of this implies, and once we're in that phase, things are really going to get out of hand. We're potentially going to have to deal with multiple different outbreak phases in different locations on the GBR, and we're going to have to be distributing our effort over a much, much larger area. Our focus is not just going to be on control, as it currently is. It's going to be on describing the distribution and the dynamics in areas where we're not implementing control, as well as focusing on control. And all of this is going to be happening under ever-increasing resource constraints, because every reef we take on becomes another cost, and there's only so much money and dive time that we can invest. So the next outbreak will be a vastly different challenge. So we have to ask a whole range of questions about our monitoring and about our control. We know, when should we manage and where should we manage? So we know we have to go as quickly as possible. The longer we leave it, the bigger the problem becomes, and it's not a linear increase in problem. We have methods that currently target and are effective against adults, and I will not go into detail now, but I will argue that we need to be focusing on adults in our in our monitoring. Other life history stages are important, but the value of that information that you get from those other life history stages is much lower in terms of how you structure and operate a control program. We need to go as soon as possible in the outbreak cycle. So if you think of the outbreak cycle as a linear sort of progression, it's not necessarily so neat. That red arrow way off on the right-hand side at the end of the outbreak cycle is where we have, to date, invested our effort in terms of monitoring and control. Now, it is a chicken and an egg problem here, but adults are the ones that are producing the larvae, etc. And so ideally, where we would be investing our effort in monitoring and in control would be in that inter-outbreak phase, detecting when adult populations are getting above critical levels and responding at that point. So I'll argue that the key task going into the future is effective monitoring of adults in the inter-outbreak period. If we fail in that to prevent initiation, then we'll have to monitor all the way through every stage of the cycle. The question of where to monitor is another important one. I outlined yesterday that we probably want to focus on the initiation box. The dispersal box that I described yesterday is probably going to be another area, but we can't afford to just do our work in those areas, because it could happen elsewhere, and it could happen at any time. We're predicting 2025, but it might have been last January, February. We don't know, so we have to be ready as soon as possible. And the design that we use needs to be able to accommodate all this kind of uncertainty, and that's no mean feat. Now, we also have to ask, what is it that we're looking for? We put a lot of focus into thinking about the triggers of outbreaks, but we've put very little effort into thinking about what's the spatial pattern of changes that we should be looking for? How does initiation occur? And I'd suggest that there are probably 3 different models that we might want to think about. And those models imply very different kinds of monitoring needs. Now, one suggestion might be that it's a point source. We have a single population or even a single individual potentially that is the source of our outbreak, and it spreads out from that area. And what that means for us is that if we want to prevent initiation of an outbreak, we have to be able to monitor every reef, every population as comprehensively as possible. That's extraordinarily difficult. The traditional sort of perspective is that there are regional scale factors that are operating. And under that kind of a model, what we might expect to see is that, a flood plume moves through, and so across a broad area, we might expect to see reefs moving in unison. That suddenly becomes a much easier thing to detect. We don't have to monitor every single reef. We can subsample or sample our reefs, and we can potentially only do it when we see, one of those triggers moving through. Another possibility is that individual reefs are doing their own thing, driven by local dynamics, and so they might pop up and then drop off again. Another one over there might do the same thing. And you only get outbreaks when you start to get synchronisation within a region, for example. And then it might spread from there. And that implies that you actually have to monitor, maybe you don't have to monitor every reef, but you have to monitor lots of reefs to be able to detect changes in that synchrony, or the evolution of synchrony amongst reefs. That might be the pattern we're looking for, but what are we trying to detect? And I would say it's going to be the presence of COTS increasing above a particular threshold. It's not enough just to say we expect COTS to be at every reef. So we need more than presence and absence. We need to be able to establish baseline densities and detect either breaches of those densities or trends in population that will bring are moving towards those densities. And we need to be able to respond effectively to that. What density we actually use as our threshold is going to be a function of a number of things, including our ability, the discrimination ability that our methods provide us. So that's what we're trying to detect in terms of the COTS, but just a note on the bottom there, we also need to be monitoring those assets at the same time. We always talk about the COTS, but it's, we're managing COTS because we want to protect coral. We need to know about that. So if we're going to be able to do these things, then we really need to change the way we're operating. We're going to need to have a robust sampling strategy that incorporates an understanding of the errors, the biases associated with the methods, and takes into account the objectives that we're trying, the sorts of inferences that we want to make from the data, and can accommodate those uncertainties. That's going to be a difficult statistical problem, particularly once we start thinking about different models for the evolution of initiation. Ideally, we'd monitor all sites at all reefs. We're not going to get to that point, but we really would like to try and get as close to that point as possible in order to minimise errors. We're going to want to do it as frequently as possible so that we don't miss a trigger event. And we're going to have, whatever methods we use in the field, we're really going to have to understand the biases associated with them. We're going to have to be able to accommodate those biases in our processes. So all of that says we need a much better monitoring strategy than we currently have. We're also going to need new monitoring tools. The methods we have are good enough for now, but we're going to the nature of the problem is changing, and so we're going to have to be able to monitor the assets in a way that we just don't do at the moment. We have sort of really small samples, sample areas that we measure across, that we apply at different sort of scales across the area we're working in. We're going to need to actually have very comprehensive information about coral type, cover, and condition and general reef health. We're going to have comprehensive information about the COTS themselves. And as I said earlier, we'll want to monitor that, have that information across all of the scales, to the extent possible across all sites, all reefs, right across the region that we're working in. That's going to demand that the methods we use are really, that they can be deployed rapidly and easily in the field. And I think, and they're going to have to give us robust parameter estimates, but critically, they're going to have to be easily integrated into field operations. It's fine for us to come up with, wonderful technical tools, but those tools have to be easy to use in the field, safe to use in the field, and and all of those sorts of considerations. So we have to be practical about the tools that we ultimately end up choosing. And it's pretty reasonable to expect that no single tool is going to be, give us all of the answers. So we're going to have a set of tools that are actually work together. They complement each other. So the information that comes out of that is going to allow us to completely change the decision-making processes. At the moment, we prioritise reefs based on essentially, in large part, guesses about what's out there and what the value of a particular site. But we only do that for control. So we're going to have to start prioritising reefs for monitoring and surveillance as well as for control. And that might entail a very different prioritisation process. More data will allow us to use a completely different approach to prioritisation. And if we have frequent and comprehensive sampling, we may be able, and ideally we would do this, to move away from modelling, which is an attempt to guess about what's out there, to actual measurements of the situation on the ground, the asset and the threat to that asset. Similarly, we currently have a decision process that helps us move in an orderly fashion through our priority reefs. We're going to have to change that, and we're going to have to start thinking about, do we need to monitor here? What's the priority of that relative to the control that's happening over here? How do we balance out those two competing demands? And how do we do, not just in terms of the amount of investment, but the timing of the investment? When should we monitor there and when should we control down here? All of those sorts of things will influence the operations that are happening on the water and our likely success in actually meeting the challenge of the next outbreak. And it's all going to flow into changes in how we operate on water. So currently, control and monitoring are essentially part of the same decision process, essentially a part of the same activities. And as we move forward, we're going to have to increase our emphasis on monitoring and surveillance. And that may well mean that we want to change the structure of our fleet. We may want to maintain control and monitoring vessels, but we might be looking for a set of smaller, more agile monitoring-only vessels that are able to cover multiple reefs in very short periods of time with a minimal investment. And I think that's an area where there are real opportunities for engagement, not just engagement of traditional owners, but for the establishment of, businesses run by TO groups that are making a real and independent contribution to COTS control in a way that hopefully would be meaningful to their own management of sea country. So ideally, the new tools will also mean that the work is easier, less risky, so on and so forth. So just in summary, the diagram on the right-hand side there, in green are the suite of tools that I think are the core components of the future monitoring program. Strong statistical design, and then a set of tools which will primarily be the culling and diver-based tools and image-based tools that will provide us with that broad-scale information about the distribution of assets, the distribution of threats, etc. Underpinning those will be a set of decision tools, data management tools, etc. Now, on the blue on the right, I've listed a couple of other sorts of monitoring approaches. These are, I don't have them in as core components. I think they provide really useful information about particular aspects of the work. And so they're things that we might use in particular contexts rather than part of the everyday operations of a monitoring program. So hopefully that's just an overview, but IPM approach has given us a strong foundation. Establishing a really comprehensive, robust monitoring strategy is absolutely fundamental to how we move forward and to any chance of success in terms of meeting the challenge of the next outbreak. And that's the sort of stuff we've all got to get engaged in immediately.